Number 8 on the 3-1, 3-2, 3-4 quiz review. Our ultimate goal here is to find a distance from a point to a line. Remember that last number there is our y-intercept, because if I plugged in 0 for x, I would get -3 for y. So that is our y-intercept, or our starting point, the starting point of our graph of our line. The slope is how we are going to find more points on this line. So the slope is 4, or 4 over 1. Remember, slope is rise over run. So we are going to rise up 4, since it's a positive, and run right 1 in the positive x direction. So at 0, -3, put a point. Go up 4, right 1, up 4, right 1. There's my graph of my line. I'm going to label that y equals 4x minus 3. And then I need to graph my point, -8, 4. There's -8, 4. So our goal is to find the distance from a point to a line, and the shortest distance is always the distance. So we're looking for the perpendicular distance from this line to point A. Now you don't want to just guess and make it look perpendicular. We have to guarantee that it's perpendicular. And to do that, we're going to use the idea that perpendicular lines have opposite reciprocal slopes. So if this is 4 over 1, the opposite's got to be negative, since that's positive. The reciprocal, 1/4. Now, because the opposite reciprocal, the slope of the perpendicular line is -1/4, and I know that this point will be on that line, I'm going to start at this point and use the slope to get more points on the line. So I start here, I go down 1, right 4 from this slope. Again, I have to go down 1 since we have a negative rise, and right 4 since we have a positive run. So down 1, right 4, down 1, right 4, down 1, right 4. If I carefully draw this line, actually I'm going to draw it as a segment, you're going to see the issue here is we do not know. The problem here is we don't know the exact intersection point. So if it would have come here and hit 1, 1, this problem would be easy. You'd find the distance between 1, 1 and -8, 4 in the distance formula, and you'd be done. But because we don't have this exact coordinate right here, we've got to find those coordinates. To do that, that's where we are going to set up and solve a system of equations with this equation and whatever the equation is for this line. And the solution to that system is the intersection point. Of course, we don't know the equation to this line yet. So we've got to find the equation to our line. To do that, we're going to use the point that it goes through and the slope of the line. If we have a point and a slope of a line, we can use point-slope form. So step 2, create the equation of your line using point-slope form. Y minus y sub 1 is m times x minus x sub 1. Plug in your slope and plug in your point, -8, 4. It's x minus -8, so that becomes x plus 8. I'm going to convert this into slope-intercept form. Distribute. -1/4 times 8 is -2, and add the 4 over. Now I have an equation to my line. Again, I drew it as a line segment, but this is the equation to the entire line that would keep going through here. And I have an equation to the other line. And I need to find the intersection point. So we set up and solve for step 3. We set up and solve a system of equations where the solution is the intersection. A system of equations. So I have my first equation here I just found, and the given equation y equals 4x minus 3. Because they're both equivalent to y, we can take this piece and substitute in for y. It's equivalent to y, you can replace y with it. -1/4 x plus 2 is 4x minus 3. Get all the x's to one side, all the constants to the other. So in the same step here, I'm going to add 1/4 x to both sides and add 3 to both sides. That would eliminate the 3's and the -1/4 x. So I have 5 equals, I'm going to show all my work on here. You could write this as 4 and 1/4 x, but I'm going to choose to write this as an improper fraction, and then I'll be able to multiply by the reciprocal to get x by itself. We need to have common denominators. So far I have a denominator of 1 here. I need to have a 4. So I multiply by 4 over 4. Multiply fractions straight across. That's 16/4 x plus 1/4 x is 17/4 x. And once again, to get this fraction to the other side, multiply by the reciprocal, 4/17. The 17 over 17 cancel, the 4 over 4 cancel. So now x is by itself. So x equals, remember this is 5 or 5 over 1. You multiply straight across with fractions, so that's 20/17. Now that we have that x of 20/17, we need to find the y coordinate. So 20/17 is just a little bit more than 1. And visually, it should look, that intersection point should look like it's just a little bit more than 1. It should be right 20/17, and then we've got to figure out how high up we have to go to hit the point. So the next piece, plug your x coordinate back into either equation. Because they share the intersection, they're going to have the same y coordinate regardless of which equation you plug it back into. I'll use the second one just because there's no fraction in it. Plugging 20/17 back in for x. I get y equals 4 or 4 over 1 times 20/17 minus 3. Multiply fractions straight across, 80/17 minus 3. And once again, I'm going to create a common denominator to add or subtract fractions. So that 3 is going to get multiplied by 17 over 17, or 3 over 1. Let's see, 17 and 3 is going to make 51. So y is 29/17. And 29/17, again, that's just a little bit more than 1. It's a 1.7. So visually, it should look like I'm going 20/17 to the right, and it's about 1.7 up. So that visually looks like that intersection point. If you got an answer like, let's say 7/3 for argument's sake, if I go 7/3, it doesn't look like my intersection point at all. So I would know I did the problem wrong, and I'd want to go back through and try to find my error. But because these visually look like I'm at my intersection point, that's my way of double checking that these are probably the correct solutions. So my intersection point, again, 20/17, 29/17. That's 1 point now on one side of the segment. The other endpoint is -8,4. If you want to find the distance between 2 points, use the distance formula. That's step 4. The distance formula, remember, is the same thing as the Pythagorean theorem. D squared is a squared plus b squared. Your a and your b are your differences of your x and y coordinates. It was d squared, but we square root both sides. There's your distance formula. Plugging in your points, you end up with d equals the square root of 20/17 minus -8, so I'll make it a +8 squared, plus 29/17 minus 4 squared. That you can plug the entire expression on the right there into your calculator. So I've got the square root of 20/17. I'm putting parentheses around that so that my calculator understands I want 20 divided by 17, not 20 divided by 17 plus 8. So close the parenthesis there, then add 8, and I want to square that entire quantity, plus 29/17, closing that parenthesis around the 29/17 minus 4, and square that quantity. The final answer should be about 9.5 units. It is approximate, so use the approximately equal sign, 9.5 units. That is my final distance from this point to this line.